Hi guys, welcome all. Uh, I just want to make sure that my voice is audible. Okay, can you please share your, please be responding in comment section, please. Am I audible? Hi guys, welcome all. I just want to make sure that my voice is audible. All right. I think I'm happy and excited to animate this particular session on Codevita. We are actually having a chain of sessions on TCS Codevita, and we'll quickly practice one or two problems if time permits. We'll practice some problems on this. Okay. So the agenda of this meeting is very simple. So we need to understand the importance of this upcoming coding competition called as TCS Code Vita. All right. So let me give you a short introduction about this. Okay. So before we get into this, I'll just introduce myself. Okay. So my name is Mohammed Salman. I'm from Face Prep and I've been in this institution for last 3.5 years. Okay. I'm a senior DSA and MERN stack trainer here. Okay. So let us keep my introduction short and let's jump into the Code Vita. Okay. So I hope everyone is doing extremely well. Okay, so today I want to talk to you about an incredible opportunity, the TCS Codevita, one of the world's largest coding contests. Whether you are passionate about coding or looking for ways to challenge yourself or aiming for a strong career, this competition has a lot to offer. So why code vita is very important? Okay, I'll give you a couple of reasons. Okay, so first thing, there are we can talk about the prize money. Okay, so if you are going to crack all the rounds, the top three people in this competition will be collectively sharing a prize amount of $20,000. Okay, so that's the first perk, and the second perk is the most commonly used perk is job opportunities. Okay, like TCS NQT, you will also you can also expect job opportunities if you are going to perform well in this TCS Code Vita. Okay, so there is more beyond this just competition coding competition. You can actually can actually make out a career from this. Okay, so how actually what is the design of this coding competition? We'll look into it now. Okay, so TCS Code Vita, it has mostly three rounds. Okay, round one, round two, and round three, which is otherwise pre-qualifier round, a qualifier round, and a finale round. Okay, so we'll talk about the pre-qualifier round in this particular session alone. Okay, so especially for those who are looking for job opportunities. Okay, if you are going to do well enough in this pre-qualifier round, that's more than enough for you. Okay, so previously it was the case, like even if you are going to attempt one question right, even if you are going to answer one question correctly in this pre-qualifier round, you will be eligible for TCS Ninja role. Okay, we all know that TCS offers three different roles: Ninja, Digital, and Prime. Yes. So in the previous years, okay, not maybe not in the very recent times, but before, right? So even if you are going to attempt one question correctly, there was people told that they got interview calls. Okay, so nowadays, in the recent times, okay, as the competition has increased, okay, we can consider that like the minimum criteria can be going up to three questions. Okay, we can, if we are going to able to answer three questions, okay, definitely you can expect interview call from this pre-qualifier round itself. So what is the structure of this pre-qualifier round? First of all, you will be having 6 hours of time in a 24 hours window. Okay, for an example, let us say you will be given with a 24-hour window. Okay, so 24th October 6:15 to 25th October 6:15. Okay, in this 24-hour window you will be given any 24-hour window, and based on that 24-hour window you can select any 6 hours of your choice. Okay, and you can work on that particular 6 hours. Okay, now when you work on those exams, you will be attempting, you'll you can solve maximum of six questions in that. You will be given with six questions in that. And talking about the difficulty, the first three questions will be from easy to medium level. The second three questions, okay, will be from medium to hard level. Okay, so once again repeat. I'm sorry, I just missed the comment. So what should I repeat? Okay, we have a comment to repeat something. Okay, fine. So let us continue with this. So the first three questions will be in the range of easy to medium, and the next three questions will be in the range of medium to hard level of difficulties. Okay, so that is how TCS Codevita can be considered. Okay, now out of these six questions, if you are able to clear three questions, three to four questions, you can definitely expect a call for TCS Ninja Road. Okay, so if you are able to clear four to five questions, okay, then you can obviously expect a call for TCS digital role. And if you're going to clear all the five to six questions, okay, then definitely you can expect a call for prime role. Okay, so that's how job opportunities are you know given for this particular TCS Code Vita. Okay, so not only that you get to enjoy competitive space, you also have actual opportunity to build a career from this itself. Yeah, yeah. So actually, I just have written welcome on the board and I'm just talking. Okay, fine. So I'll tell you more about this. Okay, so we all know the package systems as well, right? So let us just quickly go into the next part. I gave you two reasons. One is the price, other one is job opportunities, and the third one is global recognition. Okay, so the first reason. So first reason is, okay, the price amount, it is naturally very good. Okay, and the second one is job opportunities, and the third one, okay, global recognition. Okay, so you will be competing with the topmost talented coders. Okay, so this gives you a platform to see where you stand globally and push yourselves to grow. Okay, so this is how TCS Corvita works. Okay, so I'll discuss some of the strategies now so that it will be helpful for you to solve. After this, we'll try to solve some questions on, you know, we'll just try to solve one or two questions. Okay, so I'll just give you some strategies. So I'll just give you some five to six strategies here. So first thing that you need to know is we need to master the basics of DSA. Okay, master basics of DSA. I'm not asking you to master this DSA in an expert level. Okay, just be strong in your basics. Be very very strong in your basics. Okay, so that you can practice all this. You can put into implementation. Okay, so most of these questions in this competitive coding will not be mostly in a direct DP or any direct kind of questions. So most of the cases you have to apply the knowledge of DSA in a working case and you have to bring out the answers for it. Okay, so this is going to be a crucial part. Problem solving, real problem solving skill comes into play here. Just not the knowledge, just not the mere knowledge here. Okay, real problem solving skill is very important. So when how can you solve the problems? Okay, you have to understand the problem first. Okay, so the second strategy I'll give you is understand the statement carefully. Understanding the statement carefully. Understanding the problem. Okay, so that will be the second strategy I can give it to you. Okay, so only if you understand this problem statement clearly, then you can actually clear you can actually understand the problem, you can actually crack out the logic and you can actually try it out. Okay, so understanding the problem is very very important. And the third strategy that I can give you is practice. Okay, with the previous year previous year or model questions from this TCS Codevita itself. Okay, so practice with PYQs, previous year questions, PYQs, okay, or even model questions given by TCS itself. Okay, so this is very very important. Okay, so why I'm asking you to practice with the previous year questions and why I'm asking you to practice with this model TCS Code Beta questions? Because okay, when you practice with the previous year questions, you will have an idea about the level of difficulty of the problems. Okay, so second thing, you'll also have an idea about what kind of questions are being asked. Okay, so to have an idea about what kind of questions are being asked and what level of difficulty is being asked, it is very important for you to practice with the previous year questions. Okay, and the fourth one that I can tell you is, okay, learn to optimize your code. Just give me a minute. Learn to optimize the code will be the fourth step. Okay, and if you can just simply solve the question, but if you want to clear all the test cases and if you want to clear it in a very good way, you need to go for optimized code. Okay, make sure that you test your code rigorously. Okay, so manage your time properly. Okay, managing your time is very important because the question level is going to be quite interesting here and it's going to be quite high. Okay, so just give me a minute. Yeah, so it's going to be quite tough. So what you can do is you can manage your time accordingly, and practicing against time will also give you a edge over others. Okay, so time management is a very important stuff. Okay, and if you are not able to figure out a logic, okay, stay calm. That is the ultimate mantra. Okay, so if you go into panic mode, you will never get into a solution. Okay, that will be a huge distress. Okay, so talking about this rounds, okay, as I told you, we have three rounds: pre-qualifier, qualifier, and finale rounds. Okay, so pre-qualifier rounds will be based on zones. For some zones will be before that pre-qualifier rounds, we'll have some mock rounds as well. So if you are done with mock rounds, mock code vita or mock vita, if you're done with that, soon you will be having your zone wise pre-qualifier round. So if you're done with your pre-qualifier rounds, then you will be moving on to, if you are selected, then you will be processed to your qualifier and finale round. But one very interesting thing about this is nothing but it is the first two rounds or non-proctored online rounds. Okay, which means that you can take your test anywhere in your room, in your home, wherever. Okay, it is not proctored. Okay, so when I say it's not proctored, it doesn't mean that you can copy it from any source. Okay, so why I'm telling you this, because okay, TCS Codevita plagiarism checker is very powerful. Okay, so in the recent history, okay, the revelations shows that around three-fourth people are eliminated because of plagiarism. Okay, so say 40,000 people have actually cleared the round one. Okay, after plagiarism check, 30,000 people will be eliminated because of this. Okay, so try genuinely, try honestly, and try to give your best. Simple as that. Okay, so these are the things that you have to keep in mind when it comes to TCS Code Vita. All right. So, with these things in mind, let us try and solve one simple question in this in recent previous year question. Okay. So, I'll share you a question now. Okay. So, people who are watching live can just pause the video. Okay. Try to understand the logic. Okay. and you can continue it later when you have got some logic or when you have no idea about what the question is. Okay, so just take some time and then you can continue with this. Okay, fine. So I'll just show you my question now. So this is the question that we are going to solve today. Okay, in the strong room of ABC Bank, there are n vaults arranged in a circle. The amount of money inside each vault displayed on the door. So you can empty any number of vaults as long as you do not empty more than two out of any five adjacent vaults. If you attempt to break more than two of any five adjacent walls, an alarm sounds and the sentry, a sharpshooter, will kill you instantly with his laser gun. Note that as the walls are arranged in a circle, the last vault is adjacent to the first one as well. Okay, the output is maximum amount of money that can be emptied without sounding the alarm. All right. So that's a problem statement. Let us check out the input format, output format as well, and I'll explain you the question slowly. Okay. So what is the input format? The first line contains an integer n, which is the number of volts. The next line n has a positive integer of length n, giving the amount of cash in volts in the order. Okay. Output format again, maximum amount of money that can be looted without sounding the alarm. What's the constraint? N, which is the number of volts, is less than equal to 25, and amount in each volt is less than equal to 50,000. Okay, so we'll just go into the sample input here. We'll take this sample input and we'll try to understand this scenario here. Okay, let me just crop this out. We'll take the sample input and we'll try to understand with this example. Okay. All right, cool. So let's come here. Let's come to my workspace and let's work on the sample test case. Let us understand what is this all about. Okay. See, this, if you have solved a house robber question, okay, which is the most famous DP program, okay, this question will be easy for you. Okay. This question will look similar to you. Okay, this question is similar to that, but the problem here is it is a circular case, and more than circular, like in house robber problem you will be comparing with the adjacent elements. Here you have to worry about two out of five adjacent elements. Okay, there you have to worry about only the immediate adjacent neighbors. Here you have to worry about two out of five adjacent elements, any five members. Okay, take any five members. Okay, if you are given with this group of elements, you can take any five volts, any five consecutive volts. Okay, out of this any five consecutive volts, okay, you can rob or you can open any two volts. Okay, but you can not take a third volt in this adjacent five. It can be any five. Okay, it can be any five. So now let us say, okay, I am considering the first 5 volts. So if I'm going to consider the first 5 volts, okay, 1, 2, 3, 4, 5. Let us take the first 5 volts. So in these 5 volts, okay, I have to select only 2, okay. So I can, I'll be going with the maximum money, right? So that's the favorable outcome. So I'll just select these two. Yes, 5,000 and 9,000. Okay. So when I select 5,000 and 9,000, right? So this 5,000 and 9,000, is also 2 volts. Okay. It, I can take any other 5 volts. This condition is same, which is 2 out of 5 adjacent neighbors. Okay. If it is opened, it will be fine. But if it goes more than 2, alarm will sound. Okay. For an example, if I have to select one more element, and if I select 6,000, okay, what will happen now? Alarm will sound. Why? Okay, so take this 5 volts. Okay, take the consecutive 5 volts. 1, 2, 3, 4, and 5. So when you take this consecutive 5 volts, okay, 5,000 and 9,000 is already selected. And if I select 6,000 again, so it also comes under 5 consecutive volts. So out of the 5 consecutive volts, I can select only 2. Yes. So, but if I have selected third one, obviously alarm will be set. Okay, so that's about it. Okay, so this is what we are going to talk about in this particular thing. Okay, so it can be circular as well. Okay, so if I'm going to select somewhere here, right, so this like 5,000 is adjacent element of 1,000. Okay, 5,000, the vault with 5,000 rupees is nothing but adjacent to 1,000 rupees as well. It is a circular arrangement. Okay, so these are all the constraints. So given all these constraints, so let us try to write a logic to solve this particular question. It's a very, very simple one. How can we solve this? Okay, it's very simple. I will take a set of 5 volts. Okay, first thing, okay, let us discuss the logic for this. Okay, so first thing what I will do is I will take a set of 5 volts, and out in this 5 volts what I will do is I will try to find two maximum uh, volts that I can open from. Okay, I'll select two maximum volts. Okay, so here I have 5,000 and 9,000. Okay, so that's it. Okay, I can also select 1,000. Okay, but when I compare 5,000, okay, 5,000 is greater, so I'll not select 1,000. Same for 2,000 and 3,000 as well. Okay, so in this way I can have various combinations. So I'll select all the possible combinations, and finally I'll come out with the combination that gives me maximum element. Okay, so if I have tried all the possibilities in these 5 volts, now I'll try for a different set of 5 elements, then I'll try for a different set of 5 elements, then I'll try for a different 5 consecutive elements. Okay, so I will keep trying for different consecutive elements, and finally I will try to find overall amount that can be opened, okay, from the available choices. So in this particular example, so we have given the output as 26,000. Okay, so how is that possible? Okay, I'll be stealing like I'll be opening the walls of 5,000 and 9,000, and I'll also be opening the walls of 7,000 and 5,000 as well. I can open the walls of 7,000 and 5,000. Okay, now if you look at this, okay, so this condition, okay, 2 out of 5, okay, 2 out of 5 consecutive volts, okay, this condition is always true. So take any 5 consecutive elements, not more than 2 volts will be disturbed. Okay, if I take the last 5, 7,000, 6,000, 4,000, 7,000, 5,000, or start from here, 7,000, 5,000, 1,000, 2,000, 3,000. Okay, as I told you, it is circular as well. So take any 5 consecutive elements, okay, not more than 2 volts will be disturbed. Okay, so in that case, okay, this is the maximum amount that can be opened from the bank. So which is it? 5,000, 9,000, 7,000 and 5,000. So 5 plus 5 is 10. 10 plus 16 is 26,000. Okay, so that's the case. Okay, so that's the logic. Now let us go ahead and crack the output for this. Cool. So what is the steps? What is the pseudocode for this? Okay, the pseudocode for this is going to be simple and straightforward. So what I will do is, sorry, give me a minute. I'm going to use a simple recursive approach for this. Very simple recursive approach. Let us see how we can do this. Okay, first let us get all the inputs, and let us take a function, or let us take a working trigger function or wrapper function. I'm going to call it as maximum stealing optimal wrapper, okay, or something. Okay, let us start a trigger function. So in this trigger function, I'm going to create a array called as stolen vaults. Okay, this will keep track of, sorry, just give me a minute. Okay, stolen vaults. I'm going to keep track of this particular array. Okay, this array will keep track of the vaults that are selected to steal. Okay, that are selected so that I can steal from the vaults. Okay, so I'll be storing I'll be using this stolen vaults array for this. Okay, it can either contain 0 or 1. I'm going to design it such a way it will store 0 or 1. 0 means I'm not selecting this vault for stealing. Okay, one means I'm selecting this word for opening it. Okay, so that's it. I'm going to create an array like this. Okay, and that I'll start you know going for the operations. Sir, can you show the question once? Okay, so I'll show the question one more time so people who have not seen it can take a snapshot of it quickly so that we don't waste much of our time. Yeah, you can please take a screenshot of this. So one of the viewer has requested for question problem statement. I have shared the problem statement here. So I request you guys to please quickly take a snapshot of this so that we can go ahead and start solving the program. All right. So I hope it is done. Okay. So let's move for this. All right, guys. So what is the logic here? I'll be working with a current vault. I'll be working in a recursion. Okay. In this recursion, I'll be having a working parameter called as current vault number. Okay. Current vault number or index or whatever. Okay. We'll be having a variable to store the current vault. Okay. So with the help of this current vault, every time what I will do is I will check, can I steal this? First of all, I will check whether it is safe, whether is it safe to steal in this particular vault. Okay, like how will you check if it is safe or not? Okay, so when you have a array, okay, let us say 1000, 2000, okay, 3000, 4000, or something, just some random elements. Okay, now if you are at this vault, how can you confirm whether this vault is safe or not? Okay, I will look all the elements towards my left, I look towards all the elements towards my right. From this place, okay, I'm gonna consider, including this element, I'm gonna consider five consecutive elements. Okay, and I'm going to count number of volts selected in this range. Okay, if number of volts selected in this range is greater than 2, then this position current volt is not safe. So if it is not safe, okay, I will not be working on anything. I'll just simply move for next recursion, that's it. But if it is safe, what I will do, I will try for the recursion. If it is safe, what I will do is I will mark that vault in this stolen vaults array. After marking, what I will do is I will add this value in a value variable, and then what we can do, we can move for the next recursion. Okay, so we can keep doing this till we get the final answer. Okay, so that's a very simple logic, very similar to house robber problem. Okay, so let us write the pseudocode completely here. Okay, so let us say what will be the base condition for this? Okay, as I told you, my function, let us say maximum stealing. Okay, my function is going to be, recursion function is going to be maximum stealing. Okay, and what are the values, what are the parameters this function will take? Okay, it will take the vault values, which is the input. Okay, the array inputs given, right? So that will be the first parameter here, vault values. This is the array. Okay, this is the input array. Okay, and then you will be given the number of elements which you already know. Okay, and stolen vaults, that the array we have created, right? So to check whether a vault is selected for stealing or not, so stolen vaults, I'll create this, I'll be using this as well. And finally, we also need to work on current vault, CV, let us say, as a short. Okay, so what I will do here is, first thing we need, like whenever I say I'm working with whenever I say I'm working with recursion, we need to work on base conditions, right? So whenever I'm going to since we need a base condition here, let us think what is the base condition. See, I'm going to start working from the first given element to last given element. Okay, so let us set the base condition on the last element. Okay, so if I have reached the current value, if the current value if the current value has reached the last element, which is if it is going beyond or if it is equal to the original size n, then that has reached my base condition. So if I have reached my base condition, what I will do, right? So I have I have selected some elements in the stolen vault, right? So I will iterate and add, iterate and add all eligible, all eligible. Okay, I'm just writing it short. Okay, so it will be quicker. Okay, iterate and add all eligible vaults to a variable. Okay, that's it. So this will be a base condition. Okay, that will be a base condition here. Okay, so if your current vault is greater than or equal to the original size n, then you can iterate and add all the eligible vaults. What are all the eligible vaults? Okay, whenever a vault is eligible, I'm going to mark it in the stolen vaults. I'm going to mark one in the stolen vaults. Okay, so that's the base condition here. Simple as that. Okay, so if that is not the case, then what I will do is, then I'm going to follow two paths. Okay, I am going to take a path called as if stolen. If the current value is not a base condition, then I have two choices with me. Okay, what is it? I can either select the current vault now for opening and stealing from it, or I can skip it and go for the next case. So first, if you have to steal from this, what I will do, I have to check whether it is safe or not. So let us do it now. So I'll select a variable called as if stolen and I'll mark it to 0. And I'm going to check whether the current vault, if it is safe to steal. Okay, so let us say I'm going to write a function called as if is safe. Okay, if it is safe to steal the current vault, I'm going to check this out. Okay, if is safe of current vault. If the current vault is safe, then what I will do, I will mark the current vault as safe. Stolen vault of current vault, I will mark it as 1. Okay, I will mark the current vault as safe. After marking, we'll go for recurse for next step. Recurse for next vaults. I'm writing the pseudocode here, guys. Okay, so you can translate this into your own respective logics. Okay, respective languages. Okay, that's why I did not directly go for coding. Okay, I'm writing the logic here. Okay, you can translate this logic into your respective languages. Okay, so finally I'm going to try and solve this in C++. But okay, so when it comes to general live here, people will be from different programming languages. Okay, so I understand that. So I'm not going into programming languages directly. So I'm telling you the common logic. I'm giving you the common logic. So with the help of this logic, try to build the same logic in your respective languages. Okay, it will be very simple then. Okay, so if it is safe, I'll be doing this. Okay, I'll be marking the stolen vault as 1, and after marking the stolen vaults as 1, okay, I will I'll recurse for the next vault, and whatever the answer from this recursion, I will store it in the if stolen, okay, variable. If stolen variable, if stolen, whatever, I will find the answer from the recursion, and that recursion value I'll be updating in the if stolen value. Okay, so if I steal, I'll get some amount from the recursion, I'll be storing it here. So in the else case, what is the else case? Not stealing from the current vault. So if I don't steal from the current vault, is it eligible? No, it is not eligible. So if it is not eligible, what I should do? I should mark it back to 0. Okay, so else I'll mark the stolen vaults as 0. Okay, stolen vault of current value or current vault, I will mark it as 0. And what I can do, so if not stolen, let us create a variable called as if not stolen. Okay, so if not stolen, okay, simply go for next step. Like, you don't have to mark it, and you don't have to add it or do something. Okay, so if it is safe, okay, just mark the vault, go for next iteration. If it is not safe, mark the vault, go for next iteration. That's it. Okay, recurse for next vault. That's it. Recurse for next vault. Simple as that. Okay, very simple. Okay, so finally, what is the return statement? The return statement is very simple. Okay, the return statement is you have two choice for the current vault. Okay, a choice when you choose to steal this current vault, a choice when you don't when you choose not to steal from the current vault. So whichever gives you the maximum value, you have to return that. So what I'll do, I will return maximum of stolen, if stolen, comma, if not stolen. Okay, that's it. Okay, so simple as that. Okay, return maximum of if stolen, comma, if not stolen. So this will give you the final answer. Okay, now how will you check if it is safe or not? Okay, how will you check whether a current vault is safe or not? We already discussed it. Okay, I have to check consecutive five elements, including the current element. Okay, including the current element, I'll count the I'll check for the consecutive five elements. Okay, in the consecutive five elements, okay, I'll count the number of eligible vaults. Okay, so if I have already selected two vaults in that particular range, or two or more vaults, then this vault cannot be selected. So that's the simple case. Okay, so based on that is safe condition, I will decide whether to select a vault or not. If it is possible to select, I will select it, and I'll simply go for next recursion. If it is not possible, I will mark it as not eligible, and I'll recurse for next volts. Okay, I'll keep moving on and on, so till I reach the base condition. Once I reach the base condition, I will iterate and add all the eligible volts to my variable. Okay, so that's it, guys. Now let us implement this logic into C++ code. Okay, so let us jump into the code now. And I guess so let us get ready with boilerplate codes. Okay, so I'll just start with the usual boilerplates here. So hash includes. So we'll be doing this in C++. Okay, I have told you the logic. Okay, so after understanding the logic, you can try the logic in your respective languages. So iostream. Okay, so we have a constraint. So let us address the constraint here. So I'm gonna set a macro here. Call this max volts will be 30. I'm gonna set another macro here, hash define. Okay, to make finding my maximum variable easily. Okay, so max is nothing but of a comma b. A greater than b. All right. Okay, so I have set the two required macros, and now let us start with my main function. Okay, so let us go back to the main function here. Okay, so int main, let us take the required user inputs first. So I will need n. Okay, so vault values, I'm going to declare array, integer array for taking the array inputs, vault values. Okay, so it can take till max vault size. Cool. Okay, then for iterating purpose for different for loops, I will also need I. Sorry. Okay, then let's start the inputs. Let's take the inputs. Okay, I'll take the n value. Let us iterate here for I equal to 0, I less than n, I plus plus. So let us take the input for this. So say n vault values of I. Perfect. Okay, so I have taken all the inputs now. After taking all the inputs, I'll just print. Okay, let us call a function here. Call this maximum stealing. Okay, trigger function. Okay, it's not going to be actual recursion function, it is a trigger function. Okay, so what are the things I'll be passing here? I'll be passing my array vault values. I'll be passing my vault values array, and I'll pass the length of the number of volts n, which is n. Okay, I'll pass these two elements, and then finally I can return 0 for this. Okay, so main function is completed. Now let us go ahead and complete maximum steal trigger, maximum stealing trigger. Okay, so let us go ahead for this particular function now. Okay, so max steal trigger. Okay, cool. So this function takes two parameters. One is vault values. Okay, this array, and length of n. Take it. Cool. So after taking this, what should we do? Like, as I told you, how to initialize a stolen vaults array. Okay, stolen vaults array. So let us initialize this array here. Okay, int stolen vaults of n size. I have initialized the array here. Sorry, I have declared array here. And let us initialize the array values with 0. Let us initialize all the array values with 0. Okay, I equal to 0. N. All right. So stolen volts of I equals to 0. Okay. So now that we have initialized all the array values to 0, now let us start our actual recursion. Okay, so let us start our actual recursion here. So this is this function should be an integer return type function. So let us mark that return type here, and then let us go for the return here. So what is the return what is the return value here? I have to actually trigger the recursion here. So maximum stealing recursion function. Okay, let us just keep it as such. Maximum steal. Okay, so what are the parameters that I'll be passing here? Vault value. Okay, vault values array. Okay, I'll be passing the n, and I'll also pass the created stolen array, stolen vaults. Okay, I'll pass this, and I'll start the current vaults. Okay, current vault I'll start from 0. So from 0, I'll be iterating, I'll be recursing all the way to n. So I'll set the base condition on nth element. Sorry. Okay, so that's it. Now let us go ahead and write this maximum steal function. Okay, so let us go for this. So it's a return again, it's a integer type function. So max steal. So what are the parameters this function is going to take? So it is going to take vault values. Okay, it is going to take an integer n, and it's going to take stolen vaults array. Stolen vaults array. Okay, and it's going to take current vault as well. Okay, current vaults. This is a normal integer. Cool. So let's start with the base condition first. What's the base condition? As I told you. Okay, so I started from 0. So what should be the end condition? The largest value, which is n. So if current vault, okay, is going to be going beyond n, then I have reached my base condition. So if I have reached my base condition, what should I do? As I told you, I have to iterate and add all the eligible vault values to a variable. Okay, simple as that. So I'll take I variable, and I'll take a value variable values equal to 0. Okay, so for adding the relevant answer here. So for that, I'm using a variable called as values. So for I equal to 0, I less than n, I plus plus, I'll check for the eligible items. Okay, like when can I say an item is eligible? Okay, if stolen vaults of I equals to 1. Okay, if it is eligible, I'll be marking it as 1. So I'll check this out. If stolen vaults of I equals to 1, then what I'll do here? Okay, I'll keep adding the values to this values variable. Vault values of I. Cool. So that's it. So base condition is completed. Okay, so we are done with the base condition. So after adding all the values, we need to return this, right? So after adding all the values here, what we'll do before closing the if condition, I'll return the values here. So return values. Okay, so that's it. So after the if condition is over, Okay, then we can actually manage the main recursion. What is the main recursion? As I told you already, right? So we now have two choice. Okay, I can either select to steal from this choice, or I can ignore to steal from this particular current vault. Okay, so I'm going to take a variable called as if if stolen. Okay, if stolen equal to 0, I'll mark it as 0 first, and I will check if, okay, if is safe to if it is safe to steal from the current element, if it is safe to steal from the current vault. Okay, what is the current vault? Current vault. Okay, current, current vault. Okay, I'll check if it is safe to steal from the current vault. Okay, so what are the parameters that I'll need? I'll also need to pass the stolen vaults here, and I'll need to pass yan. Okay, so these are the parameters required for this. Okay, cool. Let us close this out. Okay, so once I close this, cool. So if it is safe, what I will do, I'll mark the stolen vaults. If it is safe, what I'll do, I'll mark the stolen vaults as stolen vaults of current vault as 1. Current vault as 1. Stolen vault of current vault as 1. Let's mark it. After marking it, go for next equation. Simple. Okay, so max steal of, so if stolen, I'll update if stolen as max steal of vault values, comma n, comma stolen vaults, comma current vaults plus 1. Okay, let's go for the next equation. Current vault plus 1. Okay, so that's it. So in this case, if this condition is not right, okay, if it is not possible to steal, if it is not safe, then what I will do, I'll go for a possibility where it is not possible to steal. So what I'll do in that case, so I'll go and mark stolen vaults of current vault as stolen vault of current vault. I'll mark it as false, not possible. So I'll mark it as 0. So after that, what I'll do, I'll just say, okay, I'm gonna say int if not stolen, I'm going to say it as max steal of, just simply move for next iteration again, same thing here. Okay, I'm just going to do the same thing. Okay, so maximum steal of vault values, n stolen vaults, current value plus 1, just do the same thing. Okay, if it is possible, mark it as eligible and then move for next recursion. If it is not, then mark it as not eligible and move for next recursion. Simple as that. Cool. So now we have two cases, if stolen, if not stolen. So what I have to return here, okay, now I have to return maximum of this. So let us do it. So return max of, okay, if stolen, comma, if not stolen. Okay, all right guys, so that's it. So we have only one more thing remaining to complete, which is nothing but we need to complete this. Let us make it as is safe function here. Int is safe. Okay, so what are the things I'll be needing here? I'll be taking array of stolen vaults array, int n, and I'll be also using current vaults, current vault number. I have to check whether the current vault is safe or not. Okay, like is it safe to steal or not? Okay, so let us check this out. Okay, so I'll be taking a vault index. Okay, and for iteration purpose, let us take a j variable and let's start with this. Okay, let us start our for loop here. Okay, so for vault index, let us start from current vault. Okay, I have misspelled it here, sorry. Current vault minus 4. Okay, so as I told you, I need to check for 5 consecutive elements in front, 5 consecutive elements in back as well. I mean, including this. So 4 elements in front, 4 elements in back. Okay, so let's start from here. So current volt minus 4. Let's start from here, and you know, I'll iterate for volt index less than equals to current volts index plus. Okay, so we have a for loop here. Okay, I'm sorry. So while I was explaining to you, this time remained time went out. Okay, no issues. I'll just explain that logic alone for you. No, no issues. Okay, we already know the logic. Just give me a minute. Let me quickly reload this. Was some network timeout issue, so just give me a minute. Okay, so let me just directly explain you the logic alone. Okay, it's almost time, right? So let us just discuss the final logic alone. Save function alone. Okay, cool. So here, in place of is safe, I have in this case when I was discussing it, uh, I have used the name as can I steal. Okay, so the same function. So what I have done is, if you can look at this, okay, I'll start index minus 4 to current volt. Okay, start iterating from there, and what you will do, okay, so check for the previous 4 elements, and from the current element go till less than 5. Okay, less than volt index plus 5. Okay, so that's it. So 4 elements in front, 4 elements in back. Okay, and you might be asking me, sir, if I'm starting from 0th index, 0 minus 4 will go for negative index, right? Yeah, so we have to handle it separately. So what I'll do is I'll copy the j value as idx, and I'll check if it is a negative number. If it is a negative number, what I have to do, I told you it is a circular arrangement. So what I'll do, if it is minus 4, I have to add, like let us say we have 6 members. So we'll add 6 to it. So 6 minus 4, it will go for second element. Okay, so that's how it works. So what I will do, I'll just handle the circular case in case of negative